Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Now, before I start introducing this week's topic, I want to give a shout out to Chris Warren from McRae Marine in British Columbia. Chris was kind enough to suggest last week's topic. If you remember, last week we talked about using OCS in a redundancy scheme called warm backup. So thanks to Chris for that great suggestion. If you haven't seen that video, I'd suggest you go back and take a look at that. I think you'll find that OCS can work quite well in that application. Okay, let's take a look at this week's topic, which is data-defined, user-defined function blocks now available for download and use in Cscape. Now, for this week's show, it was suggested by a good friend of mine, Bill Rainier from Open Apps in Brea, California. Bill does a tremendous job as a system integrator, and they do a lot of really innovative things with their company, and a lot of their projects are based around the Horner OCS. So thanks, Bill, for today's topic. Now, to bring in and to talk about user-defined function blocks, let's go ahead and bring in our product manager, Mr. Casey Gardner. How you doing, Casey?
Hey, not too bad. How's it going, Chuck?
It's going terrific. Now, you and I have been kind of beating the drum for user-defined function blocks, trying to convince our customers of their benefits. What are some of the benefits to our customers of user-defined function blocks?
Sure. I think one of the biggest values for a lot of our OEM customers would be to be able to easily duplicate portions of their code for whether it's repetitive processes or even creating a library of different functions that they use most often in a lot of their programs. Just to be able to easily replicate those and create their applications even faster.
Absolutely, and not having to retest the same sort of functions over and over again, but to use pre-tested snippets of code is a big advantage. Now, one of the things I love about user-defined function blocks as a manufacturer is that we can use it to enhance the instruction set in our software without necessarily taking up the time of our firmware team who's busy, designing the next generation of OCS products. So when customers often have suggestions for new functions, the applications team can very often take that suggestion and implement it as a user-defined function block, adding that function to Cscape simply by allowing customers to download the file, import it into their project, and use it just like any other function block. Really cool function for sure.
Yeah, it's a great point. We can definitely save some time from our firmware engineers.
They're always very busy. Definitely, there's never enough engineering hours to cover all the things that you and I would love to add to the product, to be sure.
Of course.
Thanks, Casey. Okay, let's take a look at how we're breaking down today's topic. Okay, we're going to, of course, introduce to you these new data-defined, user-defined function blocks, talk about what they do, what they're useful for, how they work, and of course, as always, we'll get you a demonstration. So what are these data-defined, user-defined function blocks in Cscape? Well, first of all, as user-defined function blocks, they're a set of 4 new UDFBs that you can add to any variable-based advanced ladder application in Cscape. They're available for download from YouTube. They're available from our website. When you look for this particular video after it's been recorded and posted on the website, you will find these user-defined function blocks available for download tied to this video. What do they do? Well, they allow you to search for a specific value in an arrayed variable. So maybe you've got an array, maybe it's a very large array, maybe with 1,000 different elements in it, and there's a specific value you're looking for somewhere in the array. These user-defined function blocks will return the exact position of the first instance of the value you're looking for in terms of where it resides in the array. Now, what's that useful for? Some of you may think, that seems a little bit obscure. Well, they have a variety of different uses. So one thing that Bill Rainier reminded me of when we talked about this a couple weeks ago when I was out in California is this sort of data find is useful if you're looking for a specific character in a string of ASCII characters, for instance. Now, ASCII characters are most often represented as a byte array, an array of bytes, and each character is a byte long. And you may have an application where you're looking to extract an important piece of data from a string of ASCII characters, maybe coming in from a barcode reader or something, let's say a carriage return character, and it's important for you to know where that carriage return is located in the string as you seek to extract the piece of information you're looking for from that barcode. Well, this sort of data find function would allow you to search for a carriage return in that byte array to tell you that location. Another application might be for those of you who utilize our data logging or other type functions in Cscape, where you're recording the results of tests in your machine. Maybe you're recording temperatures or pressures, whatever the case may be. And maybe there's a specific pressure value that you know you're looking for, but you don't remember, or you don't know from the top of your head exactly where that pressure test result occurred. So you could search for that value, and this function block would come back and show you specifically which test it was where that was the result you received. Another application might be if you have a parts database, and that parts database may contain part numbers and part details that you need for a particular machine function, but maybe that part database was built with the parts being added in as created order as opposed to sequential order. So finding a particular part number in that part database along with the other data associated with that part can be difficult. However, with a function like this data find, you can search for the known part number. It'll come back with the index, where is it in the database, and then all the other parameters associated with that part can be easily found because they have the same index. Now, how do these data find user-defined function blocks actually work? Well, to be able to use them along with any other UDFB, the first thing you need to do is import them into your project. So from Cscape, you can go to the Project Navigator section, and in the Logic area, you can right-click and hit Import Logic Module. And then when you select Import Logic Module, you'll be able to navigate to the folder Create that contains those UDFB files. They're actually CPU files. That's the part number extension. And then you can add those in one by one to your project for those that you feel like you're going to use in that project. You don't need to add any in that you're not going to use. Now, once they're imported, they will show up in the project toolbox under the UDFB section, where you can effectively select them and then drag them into your logic editing area to add them to your project. Now, a recommendation that we always make with the UDFBs that we create is that you should connect them to the always on contact that's connected to the power rail, so that they're always receiving power even when they're maybe not enabled to perform their function. That way they can perform whatever kind of initialization that they may need before they're actually called to action. So let's take a look at the specifics of these data-defined, user-defined function blocks. Every user-defined function block has inputs and outputs, and that's true of the function blocks that are built into Cscape as well. So let's examine these 4 inputs for the data-defined UDFBs. First of all, as I just mentioned, you'll notice that we recommend you connect the UDFB using the always-on contact to the power rail. That way it receives power all the time. Now, the enable input, which is labeled as EN, that actually is used when it is turned on to kick off the find operation. So the input should also be left on, the enable input should also be left on until the find is complete. So turn on enable and leave it on until the function block is done with its job. The next input value is called target value. That's the numeric value that you're looking for, the one you're going to search for in your array. And the format for that target value input will either be byte, integer, double integer, or real, depending on which of the 4 user-defined function blocks you're using. There's one data-defined UDFB for each of those 4 data types. Next, we have the input array that you're going to be searching through to find the value. And again, that array is either going to be in byte, integer, double integer, or real format, depending on which UDFB you're using. Now, the fourth input to the UDFB is the last index. Now, when you enter in the input array, you're going to type in the name of the variable array along with an index of 0. So that's for the third input for the input array. The last index input is strictly an integer value that represents the last index you want to search through. So let's say you have an array of 200 part numbers and you want to search through that array for a specific part number. So maybe the name of that array is part or something like that. So your input array would be input as part with an index of 0. And then the last index, if that, let's say that part array has a dimension of 200, the last index would be entered as an integer of 199. Because remember, indexes with arrays are 0-based. Now let's turn our attention to the outputs of the user-defined function block. First of all, you have a Boolean output, which is done. That output will turn on whenever the find operation is complete. Next, you have value index. So that is really the output that we're interested in, the index for the array for the value you're looking for. So if it turns out that the value you're looking for is in the very first location in the array, then that value index will come back with a 0. If it's in the 100th location in the array, it'll come back with a 99, because remember, it's returning an index, which is 0-based. Finally, the last output is an error output, which is a Boolean value, and the only real error that can be generated or can occur is if, for whatever reason, you set your last index input to the UDFB, if you set that to an improper value, in other words, less than 0 or a negative value or greater than 999. Because the largest array search that we can do using this user-defined function block is 999, so an array of 1,000 members. Now let's talk in a little more detail about a couple of the example applications where these functions could be useful. Let's start with a parts database. Okay, so let's say you have a parts database and it consists of a series of arrays with part number and then different parameters for the part. So it could be a length array, width, height, weight, etc. And all of the arrays use the same indexes. So for index number 52, that calls out the same part number and the data associated with that part number for length, width, height, weight, etc. However, let's say that this part number database was created or is constructed by listing the parts in the order where the parts were created, not any kind of numeric order at all. So finding a specific part in that list could be a challenge, but using this user-defined function block, it can become very easy. Let's take a look next. So using our data find user-defined function block, you could basically, if you know the part number you're looking for, that could be your target value. So you could search the entire array for that target value, and the function block would come back and say that part number is located at index 36. So now you know you can find all the other information on the part that you need to operate your machine, things like length, width, height, weight, etc., whatever that parameter may be, because all those other arrays use the same indexes. So index of 36 will give you all the information you need for all those different part parameters. So that's one example application where it can be quite useful. Another example would be using or dealing with ASCII strings. And very often when you're dealing with ASCII strings, it may be because you've got a string of data that's been provided by, let's say, a barcode reader. So let's say we have an application where we've got a barcode reader that's being used to read the next part number that we need to process on our machine. Okay, maybe it's a packaging machine. Now, this part number, let's say, is a numeric number. Maybe it's represented by, say, 6 digits or something. But the location of the part number within the barcode string is not necessarily always in the same consistent location. because some of the data fields are of very varying length. And so the barcode length is not consistent. And where specifically you're going to find the part number may not always be in the same indexed location within that string. However, it may be a scenario where you have a consistent prefix and a consistent suffix that is bordering the part number, which you can then use to extract the part number from the barcode. So using these data-find UDFBs is one way that you can identify where the prefix character and the suffix character are located if you're searching through a byte array, because very often a barcode will come in as ASCII characters, a series of ASCII characters represented as a byte array. Now let's go ahead and show you the second example of finding a character within a string using Cscape. Okay, so I'm going to go ahead and fire up Cscape here. And here's my project, my demo file. And this demo file is also available for download as part of the package of these data-find user-defined function blocks. So let's start out by showing you where in my project these imported UDFBs now reside. So I went ahead and imported all 4 into this project. How did I import those? Well, let me show you. I right-clicked on Logic Module and selected Import Logic Module. Then I navigated to the folder containing the CPU files. CPU files are the UDFB files. And then I did a star.cpu to find all of these CPU files available in that folder. And then I selected the one or ones that I wanted to import. Now I've already imported all 4 of these, so I'm just going to hit cancel here, but I think that illustrates how they can be imported. Now, you'll also find, if you're curious, that these 4 user-defined function blocks have not been locked. So if you're interested, you can click on them individually and you can see how they were built. And they're well commented, so you can see specifically how they were used. Now, one other thing I will mention, and that is there is a PDF file that's included in the download package that gives you all the details on these 4 user-defined function blocks, their inputs, their outputs, and their detailed operation. So you don't have to backwards engineer this particular code in order to tell exactly what they do and how they do it. That's all documented in the PDF file. Okay, let's go ahead and close this tab, and let's start to take a look at our application. Okay, so I'm going to pull up this main logic routine that I call decode barcode. So what we have happening here is it's just the example I was describing. We're getting in a string of characters from a barcode reader, and within that string of characters somewhere is the part number string that we're looking for. It's not always in the same location, but it does have a constant prefix and suffix that can help us find it within the string. Let's go ahead and take a look. Before we dive into the code, let's take a look at our setup on the bench. So here's my demo screen. Again, this file also is available as part of the download package for today's video with the 4 user-defined function blocks in it. So I'm describing the application here. And up here in this area, this is where the barcode is going to come in. The barcode string is going to come in as the barcode is read. And then down here is where we're decoding everything. So in our example, there's a number sign which identifies the prefix right before the part number string. And then there's a carriage return character that identifies the suffix immediately after the part number string. So when we execute our code, what's going to happen is we're going to see the barcode here. We're going to hit new to process the information. And then you'll see this data fill in here. We'll identify where the prefix is located using our user-defined function block. We'll do the same to find our suffix. And then we've got a little bit of extra code that I've written to effectively extract the part number string from the overall barcode string. And then at the end, we'll convert that string into a double integer value, which is our part number. Okay, let's head back to Cscape and take a look at how we built this logic using our user-defined function blocks. Anytime a new barcode comes in, we're going to get an input that's going to turn on that informs us. And then as soon as that barcode comes in, we're going to go about finding the prefix, the # character, which happens to be ASCII 35 decimal. we're going to go about finding that character in the overall string. Okay, so let's take a look at how we executed our user-defined function block. Okay, first of all, it's always on, so it's always getting power, even when it's not finding a character or finding a value. The enable input is our find prefix input. So this is an input that's going to come on and stay on for the entire time that we are processing our string, for the entire time that we're finding our index for the character that we're looking for. The character we're looking for, or the value we're looking for, is decimal 35. So, and that's because the pound sign is ASCII 35. So that's the value we're looking for in our byte string, in our byte array. The byte array that we're going to search through is barcode in. So that's the string array or byte array where all potentially 64 characters coming in from the barcode are going to reside. And then we're specifying the last index we want to search through as index 63. So we're going to search barcode in 0 through barcode in 63, looking for a value of 35. So that's what we're doing here. When this function block is complete, it's going to turn on the done bit. Okay, as long as there aren't any errors in our last index, which there can't be because I've hard-coded it, this error will not turn on, which is what we want. We don't want that turning on. And then the output of our function block is going to be the index for this prefix that we're looking for. So where in that string is that pound sign character or that decimal 35? So that's what we're doing first. Once we've successfully found our prefix character, in other words, our done bit has turned on, we can verify we got a good result because our prefix index will have a positive value. So it'll either be 0 or a positive value. It won't be a negative value. If we got some sort of error, in other words, if it couldn't find the pound sign anywhere in the string, then it would return a -1, I believe, which means it couldn't find the string. And that's all detailed in the PDF file. But as long as our done bit turns on and our value of our index is greater than 0 or 0 or greater, then we know that we can move on and find our suffix. So we found our prefix position. Now we'll find our suffix position in exactly the same way. We're searching the same array, the same range in the array, but this time we're looking for a carriage return, which is a decimal of 13. So carriage return is 13. Okay, once we're done, we'll verify the fact that we've received in our suffix. Then we're going to be ready to move just the section of the string that contains our part number into a separate string array. So in order to do that, we're going to calculate what the index location within the string where our part number starts. We're going to create a couple of indexes so that we can work our way through the strings character by character. Okay, we're going to copy starting location for our part number, the starting index for our part number. Let's say it's the 15th character. Let's say the part number index has a value of 14. So we're going to start with the index of 14 on our barcode string, and we're going to copy that into a separate string, which is a maximum length of 6 characters, because we have said in this application that our part numbers are at maximum 6 characters long. Then we've got a short little loop here, which is copying character by character from our barcode over to our part number string. And then we have a simple conversion from ASCII to double integer, because remember, a 6-digit part number that's all numeric could be big enough where it needs a double integer value. So we're going to store it as a double integer. Okay, and then when we're done with that, at the end, as part of some house cleaning, we're going to clear out our buffers and our indexes and be ready for the next barcode. Okay, so that's what's going on in the logic. Let's take a look at it on the bench. So I'm simulating a barcode coming in, 2 or 3 different barcodes actually. So let's take a look at the first one coming in. Okay, so here's the string that we read in from our barcode. Looks a little bit like gobbledygook, right? But we know that what we're interested in is extracting the part number. And we know the part number prefix is a pound sign, and the suffix is the carriage return. Now, the reason you see a box where the carriage return is located is because there is no character in the font that I'm using for carriage return. So it just shows it as a box. So what we want to do is we want to use those new user-defined function blocks to extract effectively 123 from this string. So I'm going to go ahead and enable my logic by pressing the new button. And you can see everything worked. So our prefix was identified as 14. So the index for the pound sign is 14. It's the 15th character, because remember, indexes are 0-based. The suffix is located at an index of 18. That's the carriage return. Our part number starts one further on from the prefix. That's where that starts with the 1 there. When we extract that string by itself, it's a string of 123 ASCII. And then when we convert it to a double integer, it has a value of 123. So everything works like a champ. Again, we utilize our new user-defined function block a couple different times in our logic. Let's go ahead and clear that out manually and take a look at the next string that comes in from the barcode reader. Okay, this time it looks a little similar but quite different. The part number is 5 digits long instead of 3. It's located at a little bit different part in the string. But once again, the constant is it has the prefix and it has the suffix. So we can use our logic and the user-defined function blocks to find where the part number index begins and extract the part number first as a string and then as a double integer. Let's do it one more time. Taking a look at a third string from a part number, or that contains our part number. This time again, this is where our part number resides. We can execute our logic and we can see, sure enough, we've got the part number we're looking for and all the other information we needed to get there. Okay, so that is our application example for today. That's really all the material I wanted to cover with you today. So let's go ahead and wrap up our topic. So we have just released a series of data-defined, user-defined function blocks that you can download. You'll be able to download them from YouTube, affiliated with this video. You can download them from our website just as soon as the recording of this video is posted. And again, there are 4 data-defined, user-defined function blocks, one for byte type arrays, one for integer type arrays, one for double integer, and one for real. You can import these user-defined function blocks in any Cscape variable-based advanced logic application as long as you're using, I believe you may have to use Service Pack 8 or later. I'm not 100% sure on that, but you may have to use Service Pack 8 or later because that's the service pack that I used when I created them. But these user-defined function blocks can be useful in a variety of different applications, including those involving ASCII string handling, which we demonstrated in some detail, along with some that might be used in recipes or a parts database. Once again, we want to remind you we're celebrating 10 years of the Horner Lighting Group. Congratulations to Horner Lighting on their 10th anniversary. Lots of great lighting videos available up there on the Horner APG YouTube channel, alongside all of our great automation content. Now, next week, we've got an interesting topic for you, one that you should probably take a look at if you currently use our XL series of OCS controllers. The topic next week is, should you upgrade to the XL Prime series? So we're going to talk about all the pluses and minuses, way more pluses than minuses, next week as we examine the XL Prime series. Okay, if you haven't done so already, I would suggest you subscribe to our channel. It doesn't cost anything, and we won't bug you with too many notifications. But as you subscribe, if you choose notifications with YouTube, then you'll be notified every time we post a new video or every time we go live like today. Okay, so until next week, let's all get out there and do us some good.